So today's topic, the first topic is formation of ions, right? We are going to start with a very interesting thing. And believe me, if you just understand this concept now, equations become a little bit easier, right? Compound formation becomes easier. First of all, we are going to learn about the ions, right? What are ions? Ions are basically, they are charged species, okay? So they are charged species. And you are aware of this. We have already done in static electricity that there are two types of charges, right? The charges are of two types. One is the positive charge and the other is the negative charge. Same applies with ions. So ions are of two types. One is positively charged and the other one is negatively charged. So if the ion is positively charged, we call it to be as, are you aware of?
A cation? Cation?
Yeah, cation. Yes, good. And the negative ion?
I don't know that one.
Okay, it's anion. Okay. Yeah. Now we are going to look inside the element how cation and anion are formed. What is the basic principle behind that, right? Uh, Now let me take one example. I'll take sodium, right? And I'll take chlorine. Okay. Okay, do you remember the atomic number of sodium or chlorine? Any of them?
Sodium.
Yeah.
So 14 or 12?
No, it's not 14.
Um, I can't remember.
Take your time, no issues. And what about chlorine?
Um,
Okay, no, mother, you don't know, right? Okay, I'll help you. No issues. Sodium's atomic number is 11, right? And it is 17. Okay. Now, what happens? These are the number of protons, right? Atomic number is determined by the number of protons. But when the species is electrically neutral, right? Like just elemental form, we say the number of protons is equal to number of electrons in the atom because there is no charge na, so positive will be equal to negative. Okay, so this is the basic concept which you have to remember. So that means sodium will have 11 protons and 11 electrons. Okay, so this sodium is going to have 11 protons and 11 electrons. Clear? Now, as per the configuration, electronic configuration, sodium will have the configuration of 281. Okay. In the first shell, you can fill only 2 electrons according to the formula of 2n square. Okay. N is your number of shell. Because all the electrons, they are not like they'll be fitting in one basket. No, they are arranged in some kind of orbits. Actually, it's a space. We'll study about that in in later classes, in our future classes. But yes, at this moment, I'm going to tell you that the electrons are found revolving in the orbit. Otherwise, the concept is that there is a space in which there is probability of finding an electron. So, abhi it is going to be, out of our reach. So we are not going to concentrate on that. We are going to concentrate on the number of shells. Okay. The first shell, that means n is equal to 1. So that means 1 ka square, it will be 1. 2 ones are 2. Right? So first shell is going to have only 2 electrons. Similarly, the second shell will have 8 electrons. 2 twos are 4, 4 twos are 8. Right? So 8 electrons are there in the second shell. Now, as per the concept of stability, you are studying chemistry, you are studying physics, you are studying biology, any branch of the science, all the three things are going towards stability, right? They want to attain that stable thing. So, in order to gain stability, this shell needs to have 8 electrons. Okay, and this is known as octet rule, right? Okay, octet rule, OCTET, octet rule. Okay, now it has two ways. It can do two options. It has, and it can choose any of the two options. What are the two options? either it can lose this electron, which is, creating a problem for it. Because if this is not there, the last shell will be this, and it has 8 electrons. That means my sodium will be stable. Or from somewhere, it could get 7 electrons. But fetching that 7 electrons is a big task. Energetically, it's not possible, right? So it will not go towards this pathway. No, it is totally, rejected. So what sodium is going to do, it is going to lose 1 electron. That means there is change over here. Now, protons are not disturbed, right? Now, the sodium, after losing 1 electron, it has 11 protons and 10 electrons. That means the positive charge is more than the negative charge, right? So sodium is going to develop a positive charge on itself, and hence it is called a cation. Got the point?
Yeah.
Yes. So as per the octet rule, sodium is about to lose 1 electron, thereby forming a positively charged ion. But where this positive came, because we are saying that we are taking away 1 negative, right? So the concept of positive doesn't come in our mind. The concept is that the protons are more than the number of electrons now. So that means there will be positive charge. The one who is more is going to be more dominant. Right? Now, in case of chlorine, as we have written 17, its atomic number, right? So atomic number means it is the number of protons. But because the chlorine is electrically neutral, so that means number of protons is equal to 17 and number of electrons is also equal to 17. Because we don't have any charge. Now, Hane, can you configure the atomic number of chlorine as I did in this sodium?
287.
Yep. 287. Great. So the last shell has got 7 electrons. And according to octet rule, how many electrons should be there?
8.
8. So it is short of only 1 electron. So again, it has two options. One is from somewhere, it needs to get 1 electron, right? So total will make it to be 8, right? And it will be stable. Or just keeping hand on his heart, it can lose 7 electrons, but that's not possible, right? Losing something, and that too in such a large number, is not possible. So this option is totally rejected. Okay, because of the energy, actually energy involvement. It was just to make you learn the thing, keeping the heart or this, that. It's not that. But yes, it has to be energetically, it's not possible. Because if I'm gonna lose 7 electrons, the number of protons are, way higher. So they are going to exert stronger force of attraction on the leftover electrons. They will not allow those electrons to move away. They will not. Because positive and negative, they have got very strong force in between them. Because opposite charges, they always attract each other, right? So in the case of chlorine, we are going to gain 1 electron. That means the electron has increased, right? So now what will be the situation? If the chlorine is following this path, that means protons are 17 only, and electrons, they have become 18. That means the electrons are more as compared to proton. And I told you the one who is higher in number will dictate, right? So now the chlorine will have a negative charge on it. And it's called chloride ion. And it is an anion. Okay? Yeah. So abhi fatafat se I'm gonna give you 2 elements more, and you're going to just check out ki how many electrons they're going to lose and what will be the status of their protons and electrons as per the octet rule, right? Just give me 2 seconds so that the concept is totally clear with you, right? Okay, right. Number 1, you are going to make for magnesium. Number 2, you're going to make for silicon, not silicon, aluminium, and oxygen. right? I'll tell you the atomic numbers of these. Magnesium is 12, aluminium is 13, and oxygen is 8. Okay, I'm waiting.
Will be
Yeah, 10, and the number of protons will be
12.
12. So what will be the charge on magnesium?
Positive.
Positive, and that too, 2 positive, right? So when you have, like, sodium was having a single charge, right? So it is called as monovalent ion. Mono means one, right? Valent means related to the valency. Ion means charge species. Now magnesium has got 2 plus ion. That means 2 positive, right? So it is called divalent ion. Okay. Di means whenever this di comes, na, just it should be in your mind that it is related to 2. We say na carbon dioxide, right? So di means 2, right? Aluminium. Okay, what about aluminium?
Aluminium will have the electric configuration is 283.
Yeah,
So there's 13 electrons and protons, and it will lose 3 electrons.
3 electrons. Yes, very correct. And
And then,
yeah,
and then there'll be 13 protons, so it's positive.
yep. So it will be 3 positive. Very good. So it is which kind of ion? It is trivalent ion. Okay, it is trivalent ion. Next is oxygen.
So that one will be 8 electrons and protons, and the configuration is 2,6.
Yeah,
So it,
6.
so it will gain 2 electrons.
2 electrons. So it will be 2 negative. So it is divalent ion. Right? If it is mentioned na di or tri, so it can be positive, it can be negative. Right? If I'm saying divalent cation, that means it has to be magnesium. Right? Example. Right? And in case of divalent anion, it will be oxygen. Right? See, these are like single element ions, but sometimes we have polyatomic ions also. Polyatomic ions means we'll do a short bit of this also. Polyatomic ions. Poly means many, right? Many atoms. There are more than one atoms in single charge species. They are complex ions, okay? They represent just like that only. They'll be going as group. For example, you must have heard of uh, hydrogen sulfate, H2SO4, right? H2SO4, right? So here, this SO4 is a polyatomic ion. This is sulfate. Wherever it will go like this only. SO4, right? So these you have to learn some of them, and slowly when you are writing the equations and the formulas, you will automatically, memorize them. Like sulfate ion, you have ammonium ion, right? You have OH ion, right? Hydroxyl ion. This is known as hydroxyl. This is ammonium. This is sulfate, right? Again, we have phosphate like this. So these are polyatomic ions, right? Okay. So now we have done formation of ions. Okay, we got to know this ki bhai, how the ions are being formed, which one is cation, which one is an ion. And the metals, they form cations. Okay, they will form cations because they are losing electrons. Okay, got it? Metals, they tend to form cations. And when I talk about the non-metals, they are going to form anions. Okay. Now why we are learning this? Like, what's the purpose of this? Hana? Whenever we study one concept, so naturally there is something bigger behind that concept, right? They make you learn a smaller concept, thereby leading you to a bigger door, right? Now, what's behind that door? Actually, it is the formation of formulas. We are forming these ions, and this is going to help us in many situations. Like if I want to study the formulation of compound, how would I know? How can I learn so many compounds? I cannot learn so many compounds, right? So I need to have something which I can calculate, easily. Like for example, I told you, bache, kindly make the formula of magnesium sulfate. Now you will be stuck. Array, magnesium sulfate, how I'm going to do this? Hana, I know magnesium, I know sulfate, but how to frame them together? That is the thing. That is the thing which I need to learn. Now, magnesium in the ion form, it will be written as this, right? We did that. And sulfate is 2 negative. Okay. So what happens? This charge is going to be here and this charge is going to be here. So this becomes magnesium 2 sulfate whole 2, because I told you this is a group which is going to represent together SO4, right? But this 2 and 2, they are same, so they are going to cancel out, and my formula becomes MgSO4, which is far easier to write than the full name, right? Because when we are going to write the equations, how can I write full name? It is so really very time consuming. So I am not bothered to write. So I am gonna use symbols. So first of all, tell me one thing. Do you remember the symbols of first 20 elements?
Not memorized.
Okay. And okay, you have to, because that would lead to, thinness of your ion formation, and you'll be able to learn the valencies also, right? For example, if I'm gonna ask you to frame a formula for sodium chloride, first of all, tell me the elements present.
Sodium.
Simple. Yeah, that
Sorry.
Na. Yeah, it is Na. And what about chloride?
Cl.
Yes. Sodium to we did just now. So what was the valency of this? What was the charge on this?
Sodium 12.
Sorry,
11. So it was
+1.
sorry.
+1, right?
Yeah.
Yeah. I think you're not getting. And what about chlorine?
Did we do chlorine?
Chlorine was 17. So that means it's gonna
Gain 1, so it's -1.
-1. Good. So now this valency is going to the chlorine and this valency is going to sodium. So actually, why is this happening?
I can't remember. I think it was.
Cancel out the charges, right?
This is that
Right?
new one.
It comes Na1Cl1. But 1 we don't write. 1 is supreme. So we don't need to write. Okay. So this becomes NaCl. Slightly getting up. Now you are going to make one next formula. I am not going to help you. Right? This is magnesium chloride. You are going to tell me. I am going to just write. First of all, tell me the symbols.
MgCl.
MgCl. Good. And now the charge over each of them.
2 plus and -1.
What is going to happen? They're going to be interchanged. So what should I write?
Mg -1.
1 and 2. You don't need to write the plus or minus, right? So how I'm going to write? Should I write 1 or should I remove? No. So it will become MgCl. This is the formula for magnesium chloride. This is fun, na? We just name it and we are going to make the formula, right? I'm going to give you 5 names now and you have to frame the formulas. Okay? Done. Okay. Number 1, sodium oxide. Number 2, aluminium oxide. Number 3, hydrogen. Sulfate. Number 4, ammonium. Sulfate. And number 5, calcium chloride. If you don't know any of the elements' atomic number, you can ask. Okay?
So sodium oxide would be Na +1 and then O -2.
Yeah. So the formula will become
NaO2.
Na.
Oh wait, no, Na2O.
Yes. Yeah, you just got hold of your mistake. For this, you got a smiley. Okay. Next.
Aluminium. What's the atomic number?
It's 13.
13. So it will be Na3 plus.
Yeah.
No,
Aluminium,
Na,
Al, 3 plus. Yes. And oxygen is?
-2.
Yeah. So formula will be?
Al2.
Yeah.
And then O3.
O,
3.
O3. Yes. Good. Now, hydrogen sulfate.
H.
Hydrogen is +1.
Okay,
And
H.
sulfate, na, it is -2. We have written over here, na?
Oh yeah.
Okay. Yeah. So,
So
how I'm gonna write? Just a second. My cursor is here. So, hydrogen is +1. Sulfate is -2. So, the formula will become?
H2SO4.
Yeah. And this is sulfuric acid. You know that? And it is known as the king of chemicals. Yeah. Okay. What's about ammonium sulfate? Ammonium is +1. Ammonium is written like this. NH4 whole. Matlab, it is a complex ion. Matlab, polyatomic ion. It will be +1. Okay. Sulfate,
SO4 2 minus.
2 minus. Yes. Now, how I'm gonna write?
NH4 2.
Now see, when I'm saying na NH4 2, so I have to put a bracket because this 2 is going to be distributed to both nitrogen as well as hydrogen. Okay? You
Wait,
know,
why
when,
is the
yeah, tell me.
why does the number move to the bottom?
This 2.
Yeah, because it was at the top before.
This was like the charge on the sulfate. It is going to be going towards ammonium, right? And ammonium charge is going towards sulfate. But ammonium is a polyatomic ion. So whatever is coming, na, it has to be distributed equally. Like for example, if we are siblings, na, so anything comes when, suppose for example, if chocolates are coming into our house, so it will be distributed evenly in all the siblings. Otherwise, it's a world war.
Yeah.
Yeah. So that is the point. So ammonium, in this, we have two elements. One is nitrogen, the other is hydrogen. They'll just, quarrel a lot if the valency is not distributed evenly. Right? So
Yeah.
that's why we put bracket. If you remember in mathematics, what we do, suppose I have written 3x plus 1. So I'll put a bracket and write down 5. So what does this mean? This 5 is going to be multiplied with 3x, right?
Yeah.
And also with 1. Got it, na? So here the purpose of the bracket remains the same, right? This
Yeah.
2 is going to be multiplied with both nitrogen as well as hydrogen and along with sulfate, right?
Okay.
This is the formula for ammonium sulfate. Now come to calcium chloride.
C calcium
Calcium
Ca.
20.
Sorry.
Calcium is 20. I'll let you know. Actually, it's an exception. Calcium is written like this.
Oh, okay. So
Okay.
lose.
Right? Yeah.
Yes, with 2 plus.
Yeah, 2
C
plus. Good. And Cl is
-1.
-1. And the formula will become?
CaCl2.
Yeah, that's correct. Right? So you got on to have this formula formation, right? Clear? Right.
Yeah.
Now we are going to start up with a little bit balancing. Okay? Yeah. Okay. First of all, we are going to erase this. See, in chemistry, na, writing a reaction is very important. Like for example, at this moment, I'm going to take the simplest of the reaction, which is H2 plus O2 is going to give me H2O. Okay? Here what happens, I'm just writing what is happening, right? I have just written that hydrogen is going to combine with oxygen to form water, right? This is what I have written. But if as a chemistry teacher, I'm not going to follow the law of conservation of mass, I am, doing a blunder. What does that mean? Law of conservation of mass states that I can neither create mass nor I can destroy the mass. Okay, here what I have done, see, there were two atoms of hydrogen, right? Here, two atoms of oxygen. But when water was formed, two atoms of hydrogen are there, but there is only single atom of oxygen. Where is that one atom of oxygen? I have to answer that. I cannot just simply, just banish it away. No, I cannot. I am not God. I cannot do that, right? So, in order to, fulfill the law of conservation of mass, and what I say this law to be LCM of chemistry, right? Mathematics may LCM we have done. This is LCM of chemistry, which states that law of conservation of mass, which means mass can neither be created nor be destroyed, right? Got it? Now, if I'm writing this equation, because it is just simply indicating a chemical change, that's it, nothing else, right? So it is called as skeletal equation, right? Or I can say unbalanced equations are known as skeletal equations, right? So basically, skeletal equations are unbalanced, right? I have not taken into account that the number of atoms should be the same. Now, what I can do, I am going to do, I'm going to put 2 in front of water molecule. Now see, again this concept of bracket is coming. We just wrote na 3x plus 1 and before the bracket it was 5, right? So 5 was going to be multiplied with 3x along with 1 also. Here also the same concept is going to be applied. This 2 is going to be multiplied with hydrogen as well as with oxygen. So now on the product side, number of hydrogen atoms are 4, right? 2 twos are 4. 2 times is 4. And the number of oxygen atoms is 2. So oxygen is balanced. Now again, the hydrogen is not balanced. What I'm going to do? I'm going to place 2 in front of this. Now everything is settled, right? So this is how we do balancing. This is one of the method, right? So now I'm going to give you one more equation. Let's see what we are going to do, right? It is nitrogen plus hydrogen is going to give me ammonia. Okay. Now, see what method I follow. I just write the name of the elements, right? And then make a table, reactant and product. Okay. Now I'll write down the number of atoms on both the sides. Like nitrogen is having 2 atoms on the reactant side and only 1 atom on the product side, right? And hydrogen is 2. Here hydrogen is 3, right? Now, if I am going to multiply this with 2, so it is going to become 6. But this 2 will be kept over here. That means automatically it is going to be multiplied with this, right? Now this has become 6, but this is 2. What should I do to make it 6?
Times it by 3.
Yeah, I'm going to multiply it with 3. So this is my balanced equation. Yeah, right? So, okay, I'm giving you one more equation. Now you do. H2 plus Cl2 is going to give me HCl. It's a bit easy one.
Oh, will you just put the 2 in front of the HCl?
I just got to know from your face that you got excited. Oh, this one is okay. Okay, fine. Okay, that's pretty good, right? Um, just a second.